based on his contribution to the domain. He have been associated with lot many projects in collaboration with various countries, including notably Indo-UK, Indo-US projects over there. He recently is serving as a project director on Technology Innovation Hub on data science established at ISI Kolkata with funding of more than 100 crores. He have served as a associate editor and reviewer with various journals and conferences of repute in the domain of AI and machine learning. So I request Professor Ghosh to take over session and uh, maybe it may be interesting to our participants. And everyone, try to bear with us for the technical glitch and hopefully you may enjoy the talk by Professor Ghosh. Over to you, sir.
Thank you, Ashish, for your kind introduction and invitation from the whole team of IIIT Vadodara. I hope the slides are visible now.
Yes, sir.
Okay, very nice. Okay, so I'm given roughly an hour. What
Yes,
I
sir.
try,
Yes,
I will
sir.
be trying to do in this hour is to give you a rough idea about a new topic. It's a kind of a new topic of research titled multi-level classification. Uh, Nowadays, all of us are quite aware, quite active to the field of machine learning. Everywhere in the world, every topic, every subject you think of, people are trying to apply machine learning. It has become a big hit at this moment. No one knows how long this will continue and why is such a big jump. Whatever it is, nowadays machine learning has become a kind of tool to everybody. There are a couple of commands or comments or whatever you say available in either in Python or MATLAB or some other toolbox or in deep learning or deep neural networks or whatever it is. And we are just getting some data, applying this to get the result. Now, although there is a big jump in utilizing machine learning tools in all fields, not much work has been done, not much research has been done in a topic called multi-level classification. Whatever research has been done, whatever progress has been made, is on the topics called single level classification. So what is single level classification? What is multi-level classification? Why do we need this multi-level classification? What are its utilities? How to do this? These would be my topic of discussion in this afternoon. Now look at these images. If you look at the images, these are the images of three places. The first image on the left side is the image of a sand. Nothing else is there, only sand is there. The second image is the image of a sky. But unfortunately, you will see that inside the sky, there is a little bit of cloud. And the next one, the last image, third image, is the image of a sea. You go to any sea beach, you take a picture, it looks like this. So I can say the first image is that of a sand, second image is that of sky, and third one is that of sea. So this sand, sky, or sea, this is what is the tag I can put on this. This is the level I can put on this. So this is what is called single level. Now I can design a machine learning tool and design a machine learning algorithm to identify these sort of images. think of your mail. You use mails and you have a couple of folders like primary, updates, social, spam. So a particular mail goes to only one folder. It cannot go to two folders. So it has only one tag, only one label. You can put it. There's no issue. So these sort of things are usually referred to as single level. And the classification technique or the machine learning tool that we use for doing this job is basically kind of single level classification. The problem by its very nature is single level. There's no confusion, there is no contribution, there is no contradiction in this, there is no haziness, there is no fuzziness. But look at these pictures. The first picture on top left. You can say it's the picture of sunrise. You can say it's the picture of sunset. You can say it's the picture of a sea. Even you can say it's the picture of a sky. Look at the second one, top row. So this is what you can say is the picture of sand or picture of sky. Similarly, the third one can be called a sand or a sea or a sky. So this way, if you go on, you will see that these images are not having a single level. You don't put, or you cannot put rather, I should say, a single level to this. Because that nature is something like that. So the labels that you can put on the first image is maybe two, sky and sea. The third one, it has not been put, but maybe you can say it's a sunrise also. Sun is coming out. So this is basically 2 plus or 2 label. This image can belong to 2 classes. I can put 2 labels. I can put 2 tags. Similarly, one email, maybe I can put into update as well as social. Let's say there is a tweet. That tweet is written by a sports person come politician, a celebrity come a politician. So I can say it's a political tweet. I can say the tweet is related to entertainment industry, or the tweet is related to sports. So these are the problems, these are the issues. The same object, same element can have multiple labels. And this problem is what is referred to as multi-label classification. Unfortunately, it's not so simple to solve. Unfortunately, it's not easy to solve. It's not a straightforward extension of what a single level classification is. So what is a classification? Classification is the predict the class of an unknown data set. Like for the mails, one mail comes, I'll put a tag. Say a person is having some fever and other things, so he tests for COVID. I will put a tag either corona affected or not affected. So to predict this particular class, that's what is the classification for this particular sample. How do I do that? I use some machine learning tools, some machine learning techniques, or some algorithms for doing that. So the task for single level classification is to build a system that can predict or label any unknown data into one of the known classes. So the classifier or the system has been built to predict one of the known classes. Number of classes is known. Like I said that, okay, primary, objects, social, spam. So 4 classes. Or sand, sunrise, sea, sky. 4 classes. So these are the maximum number of classes, the known number of classes. For each of these classes, I will have some known samples, and with those known samples, I will build the system. So if our system is built on some such data where each data has only one level, then I say that it is a kind of traditional classifier or a single level classifier. Single level classifier, not multi-level. Okay, so all of them have single levels, so I can train the system, I can design a machine learning algorithm to learn what are the characteristics of each of these images. And once an unknown image comes, I will put them into one of these three categories. So that is what is standard classification or single level classification. But these images, no, I cannot. If I put one tag, that would be by force I am doing that. It's not desirable, it's not expected that you will put a tag like that. You will say that, okay, this belongs to C only. That's unfair. Now the question is, why this problem was not handled previously when machine learning got such a big boom? These problems were identified. I will not say that these are not identified, but they are very difficult to handle. Not much attention was given to this. Number one. Number two is we need more samples, more images, more data to train the system for this sort of more complex problems. So big data sets are also not available. And another obvious reason is big computing systems like GPU-based systems are not available. So scarcity of resources, scarcity of data were reasons why this sort of problem was not handled much previously. But now, since we have all these things available, people are moving to solve this problem. So these are my problems of multi-level classification. These are some data where you can have multiple tags and multiple puts. So similarly, you can also come up with many examples. Say there is a movie. The movie could be thriller, and at the same time it could be a drama. It could be family drama. It could be a comedy movie. So a particular movie can have multiple tags. It's not that it has to have only one tag. So if you look at a couple of movies like this, then you will see that you can very well put multiple tags or multiple labels to them. So not only images, you go to classify movies. Yes, this is a multi-class problem. Multi-level problem. Okay. So for example, this Umbrella Academy, this has been tagged as action, adventure, comedy. It's an action thriller. It's a comedy movie. You have adventure. So all the three. So if you put these three tags, advantage is three groups of people will come to the movie theater to see this movie. If you put only one tag, the population that will come to watch this is less. So these are the real life fields where machine learning have been applied to do business. Real data on which machine learning is action. Okay. So action, adventure, drama. Bohemian Rhapsody. It's a biography, come drama, come music. So what are the tags you are going to put that will tell you how could be the business? So similarly, you look at blogs, you look at tweets, you look at posts, videos, audios, documents, news articles, all things nowadays that are coming up. And do remember that these sort of data were not previously available either. There are not much tweets, not Twitters, not many blogs, not many videos, not many audios, so whatever it is. Not much data were available previously. And now the data is also becoming more and more available. So the necessity of solving this problem is becoming much more. But fortunately, not much research has been done. So it's you who can come up with a good solution for this. Plenty of scope is there if you would be interested to do some research on multi-level classification. So what is multi-level data? To define precisely, data that can belong to more than one class at the same time. That can belong to more than one class at the same time. As I told, a tweet could be tagged as political tweet as well as entertainment industry tweet, or a sports tweet and a political tweet. A movie can have multiple tags. An image can have 3 tags or 4 tags. So basically, each image or each data is representing more than one concept by its very nature. So remember, it's not fuzzy. It's not that I cannot say with full confidence that it is this. By its very nature, it has multiple levels. So it's not fuzzy. So it's better not to forcefully assign only one tag or one label to this data. Okay. So what is the multi-level classification task? Correctly learn to classify the multi-level data and predict a final level set. So what will be the difference between my single level classification system and my multi-level classification system? Single level classification system will be trained on data each data coming from only one class. Multi-level classifier system will be trained on data where each data comes with multiple concepts, with multiple levels. So each data can represent more than one class, can come from more than one class. So it's not just, I will say that, okay, this, you give an straightforward extension of this. No, it's not that much easy. So mathematically, if you look at single level classification, the input is same, output is a single level, whereas multi-level classification, output will have multiple components. So for single level classification, input is a vector, output is a scalar quantity, just one level, whereas for a multi-level classification, output is also a vector quantity. So it's a vector to vector mapping. Single level classification was a kind of vector to scalar mapping. For each multi-level example, so if X is the input, X will have multiple components represented by its features, and Y will have a number of components representing its levels. Okay. So for any unseen instance, job of the system will be to predict this level set Y. Find this, that's a level set. It should predict the set, not only one level. So correctly learn to classify the multi-level data and predict a final level set. Prediction is a set. For single level classification, prediction was a single level. Okay, let's say I have this, if you remember the images, first image was that of a sun, second one image was that of a sky, and the third image was that of a sea. So they can be represented by a matrix like this. Sun class 0, sea class 0, sun class 1, sky class, whichever class. So it is kind of one hot encoding. Whichever class it belongs to, I will put a 1, or other places I will put a 0. Okay. So it is single level, just only one level, 1 plus 1, other places it is 0. What do you think of some other images where sea and sky both are present? So the sea column is 1, sky column is 1. Similarly, data number 5, sand column is 1, sky column is 1. Data number 8, sea column is 1, sky column is 1. So you see that in the output level, you have multiple columns with one value. So multi-level. So this is multi-level data. So previously that was single level data. This is what is actually usually referred to as one hot encoding. Only one place. In the places you put 1 where it is positive, in other places it is negative. Okay, so this is basically a kind of level set representation. How do I represent the levels with the help of a set? So this is a kind of level set representation. So in this way, I can say that single level is nothing but a subset of multi-level. So single level classification, or whatever classification we are doing today, could be termed as single level classification, or that is a kind of subset of multi-level classification also. Now, by now I think you have been clear that why do we need multi-level classification? Because the situation demands. The data is such. The nature of the data is like that. So why unnecessary wasting that? Okay, so depending upon the problem, if the problem is of single level in nature, do use that. Don't go for multi-level. It's not that for each and every problem you have to think of. But if the data demands to belong to be in the multiple classes, do allow that. And why we are doing today is what I have already explained, that storage capacity, computing power, availability data, everything has gone up. And so this is a good time to do multi-level classification. You can have a good study on multi-level classification. It's a good time. And rather I should say it's a peak hour for those people who would be interested to do PhD. Everywhere you will see that application. And user might say you are using a Vodafone connection and an Airtel connection. So you cannot be tagged as only one type of customer. You are sometimes paying in cash, sometimes paying in credit card. So your payment method is multi-level. Okay. Recommendation system, that's one of the very big applications, good applications of this. Use this. Recommendation system. Sentiment analysis. At the same time, you can be happy and you can be in tension. So multiple levels, multiple tags. So this way, if you look at, you'll see many fields are there. I mean, I have put just a few wherever I find it interesting, but it's not that. Say one image comes from the satellite, you can put multiple tags. Let's say you have taken a photograph from a satellite of Bhadodara city. You can say, okay, it's the image of the city, or you can say it's the image of the airport, or it's the image of the road. So whatever it is, depends upon what is there inside that. What are the materials actually present in that? Say, for example, human activity recognition, one of the good application areas. You are running and eating. You are jogging and eating. You are jogging and making phone calls. Multiple activities, not only one activity. So human activity recognition. Maybe one person is cooking and eating. One person is a kind of switching on something and doing something else. So plenty of application domains, plenty of fields. I am just naming a few. Depending on your background, you can pick and choose. You'll see that many such problems are available. Look at these images, remote sensing images. On the leftmost top, you can say it's the image of airplane. You can say it's bare soil, or it's grass, or there are cars. Which one do you want to put emphasis? It's difficult. And sometimes it's not possible to put the emphasis also. Say bottom left. It could be the image of sheep or dog or water. Okay. So this way, if you look at, I will find out thousands of examples, not one, two, three, thousands of examples where this sort of multi-level classification has its utility. This is one of the very useful areas, this remotely sensed image classification, because usually if you take a photograph from the satellite, a pixel contains material from various perspectives, from various objects. Say a single pixel may contain some uh, part of it as water body, some part of it as concrete structure or soil or grass or whatever it is. So forcefully don't assign a single level to this. Try to put a natural level or natural set of levels to this. Okay, so movie recommender system. If you think of designing a telephone recommender system, mobile phone recommender system, or if you think of designing a kind of hotel recommender system, so you can think of that. Okay, that this hotel can belong to this group, this group, this group, or this hotel will be suitable for this sort of people, this sort of people, this sort of people. So that hotel will sell more reservation because you are expanding the possible customer set. So these are utilities. So now, by now, it should be clear that yes, multi-level data is what is multi-level data, what is multi-level classification, why do we need it? And the next part is the real technical part. How do we do it? I will tell you a couple of tools, couple of techniques, but that's not all. I again, once again, emphasize that this is a very new field. Not much work is done, not many papers are available. So really whatever I will be telling, you will have 1001 questions that okay, instead of doing in this way, I can do in some other way, I can do in some other way, I can do in some other way. Yes, all of them will be correct questions. So that's why I say this it's an open field still today. So you can try doing something. Now, what would be the logic of your decision? That's what I'm going to tell you. Single level classification. So decision boundaries are very simple. As you can see, the class boundary between two classes, say sand and sky, sand and sea, is a very simple boundary. So determining this boundary is easy. And that is why single level classification is easy. So in classification, what do you do? Actually determine these levels, these lines. It need not always be line, it could be nonlinear curve also. So the determination of this is nothing but classification or your training. Now, since it's single level, by its very nature, these boundaries are very simple. Classification problem by its very nature is easy. But if you go for a multi-level data, you see the boundary is different. Boundary is complex. If you want to distinguish between C and non-C group, maybe I will have a boundary like this. All images on top of this boundary are C, containing C rather. All images on the other side is non-C. So it's C and non-C. But does not tell me anything. Sand and non-sand. Upper side is sand, lower side is non-sand. Sky, non-sky. So now if I want to give an image, say for example on the topmost image, you see it's on the left side of the sea and it's on the right side of sky. So it has to have two levels because both the conditions are satisfied. Similarly, if you look at the image which is at the central position, two images are there, small images. They may be satisfying all the three conditions. They're satisfying the condition of the what is that? Oh, non-sand. It's sea and sky both. Sea and sky both. Okay. On the top rightmost side, you see satisfying the condition of sea and sand. So for doing the classification, I need a combination. So the complexity is high. And this is the reason why multi-level data classification or multi-level classification is a difficult problem, is a challenging issue still today. How do you determine this? What is this combination rule, or what are the boundaries? Usually these boundaries are very complex and very non-linear in nature. Every class has a separate boundary. Like previously, every class was not having a boundary. Between two classes, there was a boundary. Now here, each and every class has boundary. It's a bounded class. Like it's bounded by sea and sand. Sea and sand. It's bounded by sea and sky. Or it's bounded by sea, non-sand, and blah, blah, blah. So the problem is very complex. That is the summary. So there does not exist many classification techniques. There are a few. So it's you who can do it. And until today, mainly two approaches are available, two approaches are used. One is called the data transformation, one is called the problem adaptation for solving this multi-class classification, multi-level classification problem. How do you do that? For data transformation, what you do is from the multi-level power set data, you try to convert it to a single level data. Convert the original multi-level data set into more simpler single level data. Then use the standard classification technique. So what you are doing? You are no more keeping this a multi-level classification problem. You are making it a single level classification problem and then solving using the standard single level classification issue. And the second method is, of course, the better method. Keep the multi-level data in its original form, adapt the existing classifiers or modify the existing classifier or design a new type of classifier to handle this data directly. So the problem could be solved in any one of these two ways. Either from the multi-level data, I will convert into a single level data and solve by using the standard classification problem, or by keeping the data as in its normal form, I'll modify the classification technique. Now this modification of classification technique is not so simple, and modification of the data does not work much. So there are issues, there are complexities, there are unsolved problems. You can venture in any one of these things. So the general philosophy of converting the multi-level data into a single level data is, say, if an image belongs to two groups, I will say, okay, that is a new class. Sand, sky, sea, these are the three classes. Maybe sand and sea is one more class, sand and sky is another class, sand, sky, sea is another class. So basically, if you can have a maximum of n levels in tanks, you will have 2 to the power n classes. You just imagine. So initially, maybe you were having just 10 classes. Now you will be having 2 to the power 10 classes. So how big the problem becomes, how difficult the problem becomes. 2 to the power 10 classes. So data conversion works if the number of classes is very less. But if the number of classes is very high, initial set of classes or single levels that I can put is little high, then it exponentially increases 2 to the power something, 2 to the power n. Initially, let's say there are 3 class classification problem. Now it becomes a 2 to the power 3, that is 8 class classification problem. If it was a 5 class problem, it becomes 2 to the power 5, that's 32 class classification problem. So designing a 32 class classification problem is difficult. So this is where the complexity comes in. But people have attempted it using the standard binary classification techniques or binary relevance, whatever name you give. Standard classification techniques that exist in machine learning, they are trying to use that by changing the data. but the data size is becoming high, the number of classes is becoming high, so the complexity is becoming more. And as a result, the accuracy is not so good. Okay. Or sometimes what is doing is, for different classes, they are designing different classifiers. One classifier, one class. If that classifier says 1, it will be one class. If others say classifier number 2 says yes, it will be the second class. Classifier number 3 says yes. So for example, sample number 6, all the classifier says yes, 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 yes. So that means you will put 3 tags. So for each class, actually you are designing a classifier. So that's what is called a binary relevance. It belongs or it does not belong. It belongs or does not belong. But you say the number becomes high. Okay. So as I was pointing out, this large input-output dimension. Okay. So the training becomes very difficult, and the complexity of the decision space increases. So you can solve it. I'm not saying you cannot solve it, but it's not that efficient. So it needs some changes. And also, if you want to solve this, you will see that there are some correlated classes. And it's difficult to segregate them. They always come together. Like sunrise and sea, sunrise and sky, they always come together. It's very difficult to distinguish. Also, you will see that data is imbalanced. So whenever you will be using this binary classifier, by converting the data into a single level data, you will face all these difficulties. So they need to be solved. There are not unique solutions for them. No available. For solving all these issues, there is no single tool. So you can think of this. Okay. So naturally, there will be many complexities, as I am pointing out. Many such complexities. The nature of the data is multi-level. So why do you convert? And even if you convert, you will be facing with all these difficulties. So it's recommended or it is expected that you will not do much on this. You will go for a standard multi-level classification. Design a multi-level classifier by changing some. So this will be your multi-level classifier. It will be initially trained on these images, and if an unknown image comes, it should be able to put the double levels or triple levels, or as many classes it belongs to. Like you can see, that is putting a sunset and a sea. You can put a sky also. It could be sunrise also. You do not know. Why do you say sunset? It could be sunrise. So complexities will be there. It's not one shot solvable. Okay. To modify the existing binary or single level classifiers so that they are capable of managing instances with several outputs. So for this, people have tried many different techniques, and until today, most successful is the tree-based ones, a kind of decision tree-based ones, or chain of trees, or classification trees, or whatever name you give. Tree-based classification techniques are more useful. People are using neural networks. They are also a good success. Deep learning techniques, yes, there is a good success. And SVM instance-based, they are also tried. I mean, as the problem is changing, people are trying with many different types of classifiers. Okay, so multi-level data, what people are trying to do, they're basically trying to change the definition of this entropy or the information gain or whatever it is. In different ways, they're trying to modify such that finally at the bottom level or at the leaf level, you get the unique levels. So different ways people have tried out MLC 4.5. Different techniques, different tools, different ways they are trying. It's very difficult to comment which one is the best, and maybe none of them is the best. because all these things are in its infancy, an early stage. So maybe whatever changes they have made, you can think of doing some more modification in that either. Or the best technique is to uh, design a completely new classifier which will work only for multi-level data. No such technique, no such tool is yet designed. Only existing things are modified and modified and modified and adapted by either changing the information gain content, or redefining the entropy, or whatever it is, or modifying the standard key nearest neighbor classifier. So people are trying to do that. Have got some success, small success, not much, not drastic, not unique. So I don't want to go into how each of them is working. These are very small material, but they are nothing but simple modification of the existing tools, and not very much successful, I would say. You may get some success with one data, you may not get success with another data. In general, it's not a good success. Okay. So I am skipping these inner details of how they actually implemented. In neural network, it's simple. You put multiple classes or multiple neurons at the output layer. Say if you have all those, say sand, for sand there is one neuron, sky there is one neuron, so for sunset one neuron. If it is a movie, then for action one neuron, thriller another, comedy another. So as many neurons will be on, you will see those many classes. So most success is either in the tree-based case or in neural network-based cases. And as on today, does not necessarily mean this is the best. Maybe you can come up with a good type of new classifier which will be much more helpful to solve multi-level data. Okay. All these things are with multi-level data. You modify this, you modify this, you modify that progression, do this for one, do it for the next, do it for the third one, and so on and so forth. Even one of my students also did a very similar thing. She just completed her PhD on this. So some kind of addition, alteration, and she more or less proposed a new idea on tree-based classification using some concept of association. One more success is in the ensemble. It's quite natural that okay, for each class you design a classifier and then make an ensemble combination. Ensemble is usually better than a single level classification, or random forest would be better than decision tree based. These are all standard things. No mention that yes, instead of doing that, you can do this. It will work. But what I'm trying to emphasize is all of them are nothing but modification of existing single level classification. None of them are actually built for multi-level classification. So my advice would be to use multi-level classification, to design a technique which will be completely dedicated for this. And this is another important issue. For multi-level classification, just classification accuracy or just precision or recall are not good measures. In addition to that, there are different types of new measures proposed, because it has to have multiple levels just to match with multiple levels. So just classification accuracy with one class may not be good enough. So classification accuracy is important. At the same time, there is something what is called Hamming loss. There is something called subset accuracy. And similar way, many measures are proposed. So maybe you can also propose one measure. I'm not saying these are the good best measures. Yes, some people are thinking, okay, this may not be a good measure, so I need something else. They're proposing. So still fertile, still open challenges are there. So not much work is there. Doing a PhD would be much simpler in this topic. Okay. Maybe sometimes you can put ranks, whatever way you feel like. I'm not going to dictate. So different perspectives or different open issues I have tried to point out, and a very natural question that comes from the students: so where are the data sets? Many data sets are available. If you go in the internet and give a search, you'll see that plenty of multi-level data sets are available. Plenty. This is usually very standard question from the students. Where are they available? Just give a search, you will get it. Multi-level data website, Relevance, you get it. Kill data set, Mika data set, many, not 1, 2, 3. Oh, you have hierarchical approach also. As I said, the tree-based or hierarchical. That also could be another way of looking at this. Okay. And newer versions are coming up. That's what is extreme multi-level classification. Extreme classification is what when you have many classes, large number of classes, large number of samples. How do you predict? You may not know the exact number of classes either. So that's what is called extreme classification problem. So extreme multi-level classification problem has also been attempted. Okay. This was for classification. As to my knowledge, multi-level clustering is not yet attempted. So if there is any brave person available in the audience, maybe he or she can try with what is multi-level clustering. I emphasize that it would be difficult. It's not simple. But if you are brave enough, maybe you can try something and you will be the pioneer. Not really some good attempts are made in multi-level clustering. Okay. So a couple of references. Only one book is available by Francisco. And a couple of other survey papers are available. And if you look at other papers, those are really contributory papers or some kind of that, not really good research to start with. So this could be a good resources to start with. So maybe I will stop here. What I tried to do last 45 minutes or 50 minutes is that I try to tell you what is multi-level classification, what is multi-level data, where does this data come from, why do you need multi-level classification, where is its utility, and what are the preliminary approaches that is available. But my most importance or most emphasis was on the open issues, open challenges. That is, there are plenty of open issues or plenty of open challenges available. So if you are interested, you can divulge into any one of these problems. Thank you. Thank you so much for your patience and listening to me.
Thank you so much, sir. Indeed, it was very nice and basic introductory talk on multi-level classification. And I would like to highlight to all the audience, it's indeed what sir suggested is a new topic and new domain. And inspired from his work, we also started working on this domain. And I also, with my PhD student, published one paper which recently is available on IEEE Access on multi-level classification domain. So that was inspired from his work only, and the resources available on his paper we refer over there. So before we go ahead, can we have a couple of questions from the audience with us, sir? We will share the PPTs and other recordings with the participants. But any couple of questions we can take up here before we go for next session.
I have one question.
Yeah,
Please.
please.
Hello, sir. My name is Dr. Rohit Thanki. I'm working in the AI field. My question is that in satellite image segmentation, we use the clustering. Means we are assigning the various labels to the image. What is the difference between this multi-level classification and that clustering? Because we already assigning these labels into the when we analyze the satellite or the remote sensing images, where we put the legs, billings, that labels on the image. So what is the difference between these two?
So when you segment the images, you put only one tag, only one label. not multiple levels. Say, for example, there is a satellite image and you have segmented the river.
Yeah.
So that
So we,
only one level you put, it is river,
yeah.
not more than
But
one level.
but in the clustering, we have put that labels like the cluster in the various, like we use the k-means clustering applying on this satellite image, and then we have get the different cluster over there. Like the river gives the one cluster, then the billing gives the one cluster,
Yeah.
like
So
that.
if you do the cluster, you cannot put any label.
Okay.
Never. You segment it into a group,
Okay.
right? Say you have divided, you do k-means clustering, you have divided into k groups. How do you
Yeah.
know that this part is concrete? How do you know that this part is river? Who told you?
Okay.
So nobody
So
knows.
yeah.
So in
Okay.
clustering, you can never put any tag that is unsupervised.
Yeah.
And classification is always supervised. You can put a tag.
Yeah. Yes.
So that is a fundamental difference between clustering and classification. So even if segmentation is nothing but clustering, you should not put any tag on that.
Okay. But we can generate the database based using that concept, if I'm not wrong.
Sorry, I cannot understand.
Means we can generate the database, like the multi-level database using the clustering approach, like doing the clustering and then put the label.
I will not recommend that, because all classification problems, the success of all classifiers fully depend upon the data, training data.
Yeah.
So if the
Yeah.
training data is determined by an unsupervised method, which is not 100% correct, then the success of the classifier system will possibly not be good.
No, means means talking about that we have not having the data multi-level data. We can
Yes.
create that data using this approach or not. My
No,
question is that.
no, you cannot, because clustering does not give you 100% accuracy. So multi-level data with which you will be training your classifier should have 100% confidence.
Okay.
So in fact, for no classification technique, the data should be generated by clustering. It should be generated by experts, domain knowledge
Okay.
people.
Okay. Okay. Thank you, sir.
Sir, one last
So
question that
I
we can.
have one question. Uh, Sir, this is Akhilesh Kumar. I am a PhD scholar at IIIT Allahabad. Sir, actually, you were talking about multi-level classification. I was wondering, actually, we are doing object detection and instance level segmentation in the digital images. So, will it be considered as a problem of multi-level classification and detection problem? Because we are doing multi-level, in fact, our data is also, we are labeling the data initially for training. So we are multi-labeling the data using image labeler toolboxes and all other similar toolboxes.
Mm-hmm.
And then we are segmenting the data also, like many standard algorithms are there, like mask RCNN and similar algorithms are there.
Mm-hmm.
So they are all supervised in nature, and they can be considered as a multi-level, in fact, beyond classification. It's a detection problem.
See, there are two issues. One is detection, classification, recognition. So these come step by step. They are not really multi-level. They come sequentially. One is a much more finer problem. One is a sub-problem of the other. So this difference you have to be very much careful. So what are you actually doing? You are putting multiple levels
Yes, sir.
simultaneously, or you are
Yes.
doing a job first and then doing a sub job. So
No, sir.
if you are putting the labels simultaneously, then surely you can say it's a multi-level.
Yeah, because it is a solved problem then. Mask RCNN came in 2017, so it's an extension of faster RCNN by Facebook AI, and they have done instance segmentation. And instance segmentation itself is a multi-level classification and segmentation problem.
I again will emphasize that segmentation is a kind of unsupervised problem.
So they segmented with supervised. There are tools available by which we can generate labels, that labels for each pixel. So we can generate pixel levels, and then that can be used for segmentation.
Oh, yes, then it is a multi-level.
Exactly, sir. That's what I was telling.
Yeah, then it is a multi-level.
Exactly, sir. Yeah. Thank you, sir.
So before we move to another session, I would like to thank you, Professor Ghosh, on behalf of our organizing team. And let me share my screen. Please accept this e-memento, sir. I understand there were multiple times glitches in hosting your session at the beginning.
It's perfect, no problem.
So thank you very much, sir.
Thank you, thank you, thank
And
you,
hope to
Ashish.
see you sometime in the face-to-face
Sure,
mode.
sure, sure.
Thank you very much, sir.
Thank you. Bye. Okay, may I take leave?
Yes, sir. Please.
Yeah.
Thank you,
Okay.
sir.
May we proceed, sir? Yes, sir. May we proceed further?
Yes, sir.